So here we are solving majority element problem. The problem statement says that we are given an array of size n and we have to return the majority element. The majority element is that element which appears more than n by 2 times. Let's see some examples. So the first example says that we have array with values 3, 2, 3 and the array length, the n value here is 3. So 3 by 2 is 1. So we have to find one value which is coming in the array more than once. So that element is 3. It is appearing 2 times. Let's see the next example. Here the length is 1, 2, 3, 4, 5, 6, 7. 7 by 2 is 3. And we have to find an element which is appearing more than 3 times. So if you see 1 is appearing 3 times and 2 is that element which is appearing 4 times, more than n by 2 times. Got the problem? Also have a look over the constraints. So it clearly specifies that the n on which we have to do this operation, that is always equals to the nums.length. Whatever array length we have, that is what n value is. Okay, and there will always be at least one value present and the array elements could be positives or negatives. Okay, so the most straightforward approach that I can think of is we can pick any element and we can check if it is coming more than n by 2 times. We will be taking a nested loop and we will be traversing from the start towards the end in both the nested loops, and we'll be checking if this element, if it is actually appearing more than n by 2 times, so then this is the point where we can say, okay, yes, this is our majority element. Got it? So if you will be presenting the solution to your interviewer will not be happy and interviewer will be expecting a better solution, optimal solution. So here's where our next solution comes. So it's famously known as Moore's voting algorithm. So idea of the Moore's voting algorithm is simple, that we have to pick one candidate and we have to cast our vote, and the candidate with maximum number of votes will be taken as the final majority element. So let's see how this will be applicable in our majority element problem. So initially we will be picking up 3 as our starting element and this is our first candidate. So in order to cast our vote, we'll increase the respective count variable to 1 value, and now if we found another instance, so then we will be increasing that count value. But if we found a different candidate, so in that case we will be decrementing our count variable. Okay, and the moment the count reaches to 0, so this is where we can actually declare a new candidate. Here if you see, initially the count value will be 0 and here the count value will become 1 and this is our candidate. Now on the next traversal item, here we have 2, so we'll decrement the count back to 0. So this is where our candidate will again be changed to 2, and now in the next traversal again the candidate will be changed and the count will be decreased, right? So this way at the end the candidate which we have towards the end of the array, that is our answer. Let's traverse this in the next problem. So here we'll pick this as our candidate, increase our count to 1. Okay, here 2 is already the same candidate, so we'll not change the candidate, we'll just update our count. So the count value becomes 2 and now we got 1 which is a different candidate. So in this case we will be decrementing our count to 1, and since it is not equals to 0, so we'll not update the candidate. So moving on to the next traversal item, we have again 1. So this is where the changes will be happening. Now the count will be reduced with value 1. So now this is where the changes will be happening, and now since this is a different candidate, the count value will be decrementing and it reaches to 0. So this is where the candidate will also be updated, and now the new candidate is 1. So next we again found 1. So this is where we will be actually updating it again. Okay, so the count value becomes 2. Now we got a different candidate and we'll decrement the count value. Okay, so the count reaches to 1. Now in the next one it reaches back to 0, and this is where our candidate will be changed, and now 2 will be our candidate. So got the idea, right? I dry run every scenario, and this is where this problem, this algorithm will always be helpful to us. Okay, also stay tuned towards the end of this video as we will be applying ES6 concepts on the Moore's voting algorithm as well. So let's dive deep into the code and let's begin with approach 1. Let me just increase the size of this window. And as discussed in the approach 1, we will be basically traversing the array from the beginning towards the end. Okay, and again we will be traversing the array from the beginning towards the end, right? This should be j less than nums of length and j plus plus. Got it? So here when we are on this point, what we'll say is we'll check if my nums of I is equals to nums of j. So in that case we'll increment our count. Okay, and we'll initialize our count over here. Let count equals to 0, and after that we'll check if my count is actually greater than the n by 2 length, right? N by 2. So if that is the case, so I can simply return my nums of I. This will always work, but in order to avoid any warnings, so I'll just return -1. Let's check against the custom test cases. It passes. Let's submit this problem. Cool. So it passes all the test cases, and now let's move on to the approach 2. So let me again arrange my screen. Okay, approach 2. So Moore's voting algorithm. Let me write that also. Let's start. In the Moore's voting algorithm, we have to declare a candidate. Okay, and initially the candidate could be -1 only. Okay, our count, which will be 0. Okay, and now let's traverse the array from the start towards the array length. Yes, now we'll simply check if my count is actually 0. So this was the point, right, where we were doing two operations. One is we will be updating our candidate to be as nums of current iteration, and we'll also increment our count, right? Okay, if it is not equals to 0, so then we'll check if my candidate, if my nums of I, the current element, if actually it's the same element which we casted our vote for. So in that case we'll say okay, we just have to do count plus plus, else we have to do minus minus count, right? And at the end we will be having our candidate, and we can simply say that please return my candidate. Okay, let's test. Cool. And submitting this problem, and it passes. So it's simple, right? Okay, so now moving on to the ES6 way of solving this problem, and it will be just a optimized version for this one. So for this time I will be actually converting the same solution into the ES6 way. We will be still utilizing these variables, and I'll use them here also. So let me rewrite this for loop into a ES6 way, and in order to write that, we'll declare a for loop and we'll declare a for off loop. So const num of nums. Okay, and this thing, right? So this thing is still required. We have to still update the count. So we can say if count is 0, so then our candidate will be num, and now we'll do addition on a simple condition. So the condition will be this thing only. So if my num, current num, if it is actually equals to the candidate, in that case we have to increase by 1. Okay, and if not, then we have to decrement by 1, right? And now we can simply return our candidate. Simple enough, right? Let's test. Okay, it's num, not that dot. Okay, it passes, and let's submit this. Cool. Here we are able to solve this problem, and let's now analyze the time complexity and the space complexity. Again, let me rearrange my screen. Here, if you see the time complexity for this, for obvious reason, seeing the two loops, it's order of n square, and we are always going from start towards the end, right? In the worst case, it will always be order of n square. And what about the space complexity? So the space complexity will be order of 1, right? because we are just declaring a simple variable. Okay, in the next Moore's voting algorithm, the time complexity, yes, it will be order of n, because we are just traversing only once, so it will be order of n. And what about the space complexity? It will be order of 1, right? Okay, and in the last one, ES6 way, I think it is similar to what we have above. Time complexity over here is order of n only. This is the same thing that we are doing over here, just a syntax difference. And the space one, again, it's the same, order of 1. Okay, so if you ask me what is the better way to present to the interviewer, any of these solution, the ES6 way or this one, would be a better way to present in front of the interviewer. Okay, that's all. Thank you.